what you should now see is my AMP console. We're now having our view inside the running AMP control plane. AMP has been deployed to supervise some of these very important business critical workloads. AMP is deployed as a server application in our estate, but it comprises several modules. The modules allow us to build application models, which AMP can then execute and use to understand the state of the applications under its management. And once built, we can then use the detailed inspector capabilities to observe in a very consistent way, observe and manage those applications under management. So to tackle the modeling aspect first, at the heart of AMP, we have a catalog of component and system models. It's very composable, very open source, based on an open source representation standard called CAMP, which has come out of the Oasis group. And the catalog allows us to wear different hats. We can put on our subject matter expert hats, or we can put on our system composition hats, and we can build really quite complex systems out of components that we know are following best practices. So if we were to switch to the composer here, the complex escalating failure recovery policies of, in this case, a bank, have been modeled using the primitives that AMP exposes in its catalog. So we have zones which are grouped into regions, and within each zone we have some web components, some application components, and some data components, with policies, crucially, policies attached to each tier so that the failover can be coordinated and executed as the customer wants. Just to give you a little view, a little bit of insight into how comprehensive the application modeling capabilities of AMP are. In this particular example, we've modeled an entire application, even though different tiers of the application are actually running in different infrastructures. So we've actually got 3 different locations representing the 3 different data centers, the availability zones, if you will, across the customer's on-premise state. But because AMP can also talk to public cloud platforms, everything from bare metal on-prem servers through hypervisors for your on-prem environment, container platforms, and public clouds, you can actually have an AMP model which spans multiple, not just data centers, but multiple clouds, multiple completely heterogeneous types of infrastructure for a single workload. And the policies that we can also attach to each individual piece of the application can also span the different tiers of the application to do exactly the right thing. The policies that we ship with, and as we've said throughout, AMP is extremely unopinionated and very extensible through the addition of custom Java classes that your developers may wish to write to encapsulate complex logic, or simple YAML component blueprints or system blueprints to encapsulate best practices and subject matter expertise without having to write Java classes. By adding them to the catalog, they're available for selection by the people who are building up these models to be deployed in AMP. And it's not just these entities that are part of the model, it's also different locations. So our different data centers will show up, our different target infrastructures will show up available for selection, and its policies. So we can actually attach a complex range of automatic management behavior to the different parts of the tree. And this was what the customer wanted in the example we were talking about before. Simple low-level failures can be remediated generally with a simple policy. We'll simply restart a process that has crashed, or we'll re-provision a virtual machine that has maybe gone faulty. But as the failure modes become coarser and the blast radius extends wider and wider, we may actually, in this particular banking customer's case, fall back to a manual approval for the coarsest type of failover, which would actually involve failing over from one side of the country to a zone on the opposite coast. Once the model has been built, and again, this is quite a complex set of failover policies that interact in cascade, but once deployed, and I can switch to the runtime view of that system once it's been deployed, we can actually see this wide area tertiary failover application has been deployed down here. And that entire structure of componentry and policies are now visible in the runtime view. This is the system as it's been deployed in 3 separate locations. So we can actually see our 2 geographies, our 2 regions, one of which has 2 availability zones hosting the application and its data, and there's a failover zone on the opposite coast. And if we were to inject failures, this will happen very quickly, but if there's a failure in one of the zones, inject a failure in the north zone, we should see the web app tier we've injected a fault, but AMP, through its automation, we are able to dynamically recover from that without any manual intervention. AMP takes the necessary steps because it understands the internal structure of the application and the internal management logic that the customer has specified. AMP is able to, without any manual intervention from me, recover automatically, and the service goes green. And the service status bubbles up from the individual components all the way up to the top level, providing a very consistent, very easy to read snapshot view of the status of my application estate. That is also reflected in the dashboard, which is maybe a rolled up, more easy to consume but less detailed view for people who want to have a more overarching view of the business critical applications that are in scope at any given time. You can imagine that we can model and deploy lots of our critical business applications. So if we were a bank, we may expect to see certain critical services like our core banking platform, our digital bank processing platform, coupled with our engagement platform. These may be developed in completely separate styles by very different teams. The core platform may be very, very on-prem, very server-oriented with lots of high availability and some big iron servers, whereas the engagement platform may be developed in a more agile manner, deployed in a microservices architecture on a container platform, maybe utilizing more cloud infrastructure platform or even software as a service. And AMP can encompass that entire digital platform, regardless of the heterogeneous pieces and how a mixed bag they are. AMP can not only view those pieces, but also reach out and manage them through either manually invoking these management operations, which are exposed through the UE, or as we've seen, joining up, closing the circuit between observing an event which needs remediation and having a policy automatically take the action to fix that issue without any manual involvement.